Ciao. Ciao. Chi ha già visto, non la presentazione, questa GIF voglio. Ok, allora è nuova questa, vedi, l'ho aggiornata. Ottimo. Oppure non eravate attenti l'ultima volta. Vabbè, vediamo. Comunque, giusto per dirvelo, quella è l'unica cosa che è cambiata. Tutto il resto non è cambiata una fava, proprio zero. No, dai. Comunque, piacere Gianluca, per chi non mi conoscesse, così mi può trovare su internet. E quando faccio le presentazioni sto così, quindi adesso vorrei scappare, perché purtroppo non nasco presentatore. Allora, cos'è lo spazio? Che è forse la cosa un pelo più tricky da chiarire. È un coworking? No. Ok? Questo non è una cosa tipo il Talent Garden, questo è l'ufficio di un po' di aziende. La principale qui dentro è Mica Mai, lavora in ambito web, utilizza varie tecnologie, quindi abbiamo un paio, qui altre, e qui invece abbiamo i suoi clienti, alcuni dei suoi clienti più che altro. Aziende che fanno videogiochi, un po' di finance e moda. Ho detto all'inizio che qui dentro ci sono un po' di aziende, infatti Mica Mai non è da sola, lavora con altri partner qui dentro, una di queste aziende è LinkMe, fa lo stesso lavoro di Mica Mai ma con delle tecnologie diverse. Un'altra azienda è Jack Magma, è uno studio di design. E cosa fanno queste aziende? Qui dentro lavorano durante il giorno. Da un po' di anni però a questa parte hanno deciso di fare una cosa. Loro hanno sto spazio, la sera e il weekend lo spazio rimane inutilizzato, c'è qualcuno che uno spazio così, insomma, ce l'ha bisogno, e quindi cosa hanno fatto queste aziende? Dice, vabbè, sai cosa? Lo apriamo, lo diamo in maniera gratuita a chi ne ha bisogno, nello specifico alle community tech milanesi. Allora, questa cosa di volontariato, mettiamola così, a questa, diciamo, pratica di volontariato si è unita un'altra azienda che presta la mia figura, l'azienda per cui lavoro io, credi, una startup fintech, presta la mia figura per appunto dare una mano alle community milanesi. Perché si fa sta cosa? Perché ci piace, a me piace, e a me non solo, perché appunto non sono da solo a fare questa cosa, ma anche a queste persone piace, Mara e Francesco, che lavorano per Mica Mai e LinkMe, e appunto ci piace fare questa cosa e la facciamo. Ora, sicuramente le aziende che ci stanno dietro hanno un ritorno di visibilità, ma non è il motivo per cui si fa questa cosa, ok? Il motivo principale è che a me, Mara e Francesco piace, punto, that's all. Raga, è vero, ok? Ragazzi, stasera JUG è incontro numero, io ormai ho perso il conto, 105? Quasi cifra tonda, mezza, vabbè. Però è un evento speciale stasera abbiamo Klaus, non è banale come serata, insomma. Vi ringrazio ogni volta, lo farò sempre, continuerò a ringraziarvi, per noi è sempre un grande onore. La marchettata, Mica Mai sta cercando sviluppatori Node, quindi JavaScript backend e frontend React, quindi per qualunque cosa scrivetemi, gianluca@micamai.com, qui i miei riferimenti. E adesso io di solito mi dileguo, ma adesso sì, in effetti mi dilego, ma prima faccio una cosa, faccio una sorpresa, alzo la palla a Enzo del CodeMotion.
Pensavate di esservi liberati
E invece
tutti chiamatemi Enzo, no? Innocenza, chiamatemi Enzo di CodeMotion. Immagino che tutti conosciate CodeMotion. Tutti? Devo spiegare che cos'è? No. Sono il community manager, insieme a me c'è pure Valentina, community manager su Milano, e sono qui. Vabbè, applauso, vai. E dai, ne varrà la pena, perché probabilmente chi c'era l'anno scorso quando ho fatto la stessa presentazione, quindi già sa, gli altri sapranno fra poco. Intanto vi presento la prossima nostra conferenza, che sarà appunto a Milano 29 e 30 ottobre. Novembre, scusate.
Sicuro che la data sbagliata, cioè, non ne vediamo più figure.
Abbiamo cambiato sede, avevamo già cambiato sede l'anno scorso, visto che qualcuno ha avuto da ridire, l'abbiamo cambiata pure quest'anno. Speriamo che non ci saranno problemi, però dai, è super figa, quindi infatti pure dalla faccia della GIF che ho messo promette bene, a Porta Genova, super studio. E per chi non conosce CodeMotion, non c'è mai stato, la conferenza si divide in 9 track parallele. Questi sono gli argomenti principali, quindi languages, mobile, game dev, security, big data, microservices, design UX, tanti talk ispirazionali. E quest'anno il focus quindi sarà su intelligenza artificiale e machine learning, deep learning, blockchain, architetture software, poi tutta la sfilza di realtà, quindi aumentata, mixed, virtual reality, DevOps, la cyber security e poi lo sviluppo front-end. Stiamo annunciando i vari keynoter. Mario, tu quest'anno non ci sei? No, non è che... No, ci sei come speaker ma non sei come keynoter, no? Giusto, ok. Quindi avremo John Romero. Chi ha giocato a Doom 2? Chi conosce John? Vabbè, quindi conoscete, è lui, che tra l'altro avrà pure un'area espositiva dove vi sfiderà personalmente a giocare a Doom. Quindi sappiatelo. E ci saranno grossi premi, dai, però sarebbe figo riuscirlo a sconfiggere. Quindi, dopodiché avremo pure il keynote di Netflix, che dovrebbero aprire la prima giornata, perché i keynote sono 2 il primo giorno, 2 il secondo giorno e 1 poi di chiusura. Poi abbiamo GitHub, gli altri 2 li annunceremo a breve, quindi seguite il sito, poi lo troverete dove l'agenda è in continuo aggiornamento, anche se stiamo ormai agli sgoccioli. Gli speaker vengono da queste aziende e non solo, queste sono le principali, ma ce ne sono tante, ci sarà pure Mario confermato tra gli speaker. Avremo, quindi non è solo conferenza, avremo pure delle aree espositive, quella dedicata agli sponsor, i grossi che avete visto prima, però tante anche piccole aziende che sono ben liete di accettare i vostri curriculum se siete alla ricerca di un nuovo lavoro. Avremo l'area Game Dev dove potrete sfidare, come vi dicevo, John Romero, e poi l'area Community. Quindi ognuno porta il mulino l'acqua al proprio mulino, ogni volta mi confondo. Quindi sarà l'area Community, avremo uno stand dedicato alle community dove già vi siete prenotati, giusto? Vi stavate informando per prenotarvi. E poi abbiamo pure, alla fine della prima giornata, 5 meetup. Spero quindi che ci sarà pure il vostro, delle principali community del territorio. Quindi 18:30, dopo il momento della birra, ci sta un'ora dedicato a 5 community. In definizione, però credo già la prossima settimana saranno annunciati e saranno in agenda sul sito. Prima sorpresa della serata, abbiamo uno sconto per chi non ha ancora preso il biglietto del 50%, il più grande di sempre. Già le community hanno uno sconto più grosso e tutti gli altri si lamentano, ok? Lo distribuiamo del 40% perché Codemotion, per chi non lo sapesse, nasce proprio da un Java Day di tanti anni fa di Roma. Quindi questo è lo sconto, poi ve lo manderemo pure, però se volete fate una foto adesso perché dura 48 ore, lo faccio partire da ora. Quindi spicciatevi, si dice a Roma. Torno indietro? Scusate, torno indietro un attimo. Scusate, fate la foto tranquillamente. Avete fatto? No? Fate pure. Posso andare avanti? Oltre alla conferenza, i 2 giorni precedenti, 27 e 28, ci sono 4 workshop. I workshop sono un'intera giornata di formazione su questi argomenti. Abbiamo i primi 2 che sono dedicati alla blockchain e al deep learning. E poi vado già avanti e poi ritorno indietro, non vi preoccupate. E poi ci sta quello dedicato a Kubernetes e ad Angular. E sono riuscito a strappare alle mie cape pure per Milano lo sconto indipendente pure sui workshop, perché prima non c'era. Quindi tanti che avevano preso il biglietto praticamente dicevano voglio lo sconto community pure sul workshop. Ci sta un combo che è il 15% su tutto, invece così potete prendere il 15% sul workshop e il 50% sulla conferenza, ok? Quindi questi sono i codici per prendervi lo sconto community su workshop. Se mai torno indietro, questo qui è su quello di blockchain e deep learning. Arrivati in avanti, ok, tutto tanto poi chiederò di mandarli, ok, glieli mandi così. Mi mandi il list. Ecco, un motivo in più per esserlo. Stiamo cercando docenti per fare formazioni in tutta Italia, poi se volete ne parliamo alla fine del meetup. Questi sono i principali argomenti, ma non solo, quindi se siete confidenti in una disciplina, se siete confidenti nell'insegnamento, ne parliamo dopo. Faccio evidenzio soprattutto Scala, stiamo cercando assolutamente su Scala in questo momento, ok? Quindi se conoscete pure qualcuno, fatemi sapere. E siamo arrivati. Allora, prima sorpresa della serata, per ringraziarvi, birra e pizza in abbondanza per tutti. Ok, ritorno, scusate, ho fatto un danno premendo qualche bottone. Qui, meno male controlli, vai, perché sennò... Quindi questo è il nostro gruppo su Facebook dove di solito mettiamo tutte le nostre iniziative e ci tengo in particolar modo a questo progetto che è appena lanciato, un programma per l'università, Codemotion for You, dove il 4 sta per la U sta per University. Quindi stiamo cercando ambassador, quindi tra gli studenti che saranno un punto di riferimento per Codemotion, riceveranno tanti gadget, benefit e saranno appunto la voce di Codemotion nelle proprie università tecniche stiamo parlando. Se andate sul canale c'è già il modulo per candidarsi, quindi se siete studenti, io lo sono ancora, pure se ho una certa età, sappiate. Quindi oppure conoscete studenti, potete farli registrare e segnare se sono appassionati di tecnologia. E poi in parallelo abbiamo avviato pure il gruppo dedicato agli hackathon italiani, dove pubblicizziamo i nostri hackathon, quelli degli altri, ma soprattutto vuole essere un modo pure per proporvi del materiale riguardo agli hackathon. Sia se siete vincitori seriali, come ci sono tanti gruppi, conosco, sia che volete partecipare al primo hackathon, quindi interviste, consigli, e vogliamo pure voi che partecipiate. Ok, quindi entrate e ne vedremo delle belle, dai. Ho quasi finito. Per questi, a proposito di hackathon, abbiamo 2 hackathon a Milano. Il primo a fine ottobre, non mi sono sbagliato in questo caso, 5.000 euro di premio di Agos. E poi quest'altro di Dell sarà in mezzo alla settimana, il target è soprattutto studenti, però in realtà è aperto a tutti, all'interno del forum appunto di Dell che si terrà qui a Milano il 14 e 15 novembre. E fine, io penso ho finito, mi taccio, grazie mille, alla prossima.
Rubo anche io un minuto a Klaus per un paio di annunci. Allora, come avrete capito dalle nostre bellissime magliette, stiamo andando avanti col progetto del Voxer Days a Milano. Sabato ci sarà, questo sabato, quindi dopodomani, ci sarà l'evento a Lugano, fate ancora in tempo a partecipare se volete. L'evento a Milano finalmente è confermato, sarà il 13 aprile in Bicocca. E, quindi, come vi dicevo, sabato ci sarà l'evento a Lugano, lunedì apriamo la call for paper per questo di Milano. Siccome vogliamo fare un processo di selezione quanto più trasparente possibile, ci farebbe piacere trovare 3 o 4 persone fra di voi che ci danno una mano con il programma committee. Quindi, però, ve lo dico prima perché l'ho fatto in passato e continuo a farlo. Far parte del programma committee di una conferenza è un bel impegno, quindi se siete interessati contattatemi offline, più o meno tutti sapete come fare. Che più? C'è un altro evento di cui ovviamente non mi ricordo niente, un attimo. Ok, quindi c'è un evento invece a Torino che si chiama Visionary, è organizzato dal Politecnico di Torino. L'evento sarà il 1° dicembre appunto lì a Torino. Il format è una giornata, c'è un palco principale, ci sono 8 speaker, 75 tavole di lavoro e sono previsti 600 partecipanti. Alla fine verrà formato in maniera sociale, in maniera condivisa, un manifesto della conferenza. Quindi è un evento anche questo carino. Se volete partecipare, come vi ho detto, è il primo.
Questo evento, scrivetevi un'email list per la vostra candidatura in modo tale che vi mettiamo in contatto con gli organizzatori, ok? E praticamente potete partecipare come soci, cioè come attendees del JUG Milano per questo evento.
Ok, quindi abbiamo finito, finalmente cedo la parola a Klaus. Grazie di essere venuti. Thank you, Klaus.
So, just a warning, I do not have any animations in my slide. There's no funny cats or whatever. No, sorry, it's corporate slides. I don't have that talent, you know.
But there is Mr. Camel.
Yes. So, okay, so don't you know, I am Klaus Ibsen. I'm here to talk about Apache Camel, and I have a friend with me. This is my friend. He's known as Mr. Camel. It is a spirit animal for the project, and he's a bit of a grumpy camel that has a different personality than me, and we make it fun of that. So he goes out. He's kind of like to drink, and so that's the good part of Camel sometimes. So, and he even has his own Twitter handle. So I like a little celebrity for Camel. So good. This is my first town visit to Milano, the city at least. I have been here before. I actually thought I went to Milano, but they went to Novarello instead. So we stayed out there in Novarello, me and my team, or the Fuse team. And then, okay, I thought it was a bummer, but apparently this is a sport facility where the local football team, Novarello, also do practice and whatnot. So it was quite a good facilities. But I'm pleased to be back here and have the chance to actually be in the city. However, there was one good plaything in Novarello. So I had myself, riding a camel. Anyway, we had great fun of that. So myself, I am a software engineer. Well, I guess most of you are also software engineer, or maybe some guys are just here for the beer and the booze. So you have to suffer for 50 minutes or so before you get the beers. I've been working with Camel for 10 years, even as a paid software engineer. That's quite good. I also wrote a couple of books on Camel. I have one here with me. This is the, we call it the quick start for Camel. So I have one as a giveaway. So we have to figure out how to do that. Maybe a raffle, a good question, or you guys are helping organizing that. So, and I can also sign it. So I'm based in a small country called Denmark. Everybody here knows where it is. But if I go to the States or somewhere, they think it's a city somewhere or something like that. I have lived and worked 10 years in Sweden. So some people mistake me as a Swede. But the languages are very similar. It's like English, Scottish. Sweden is sort of like my second home. But I'm back in Denmark again. I put up some contact details where you can reach out to me. So how many people know about Camel? Wow. Okay, so for the recording, that's quite a lot. That's maybe 15%, 20%. Okay, so let me ask again. How many are using Camel in a production system, something like that? Okay, that's better. So 80 or 90% are not doing that. So let me introduce you a bit to Camel. So what is Camel and what do we use it for? So Camel is used for integration or system integration. So when you have all different IT systems, then Camel is sort of like that software piece that sits between the system and integrate them, glue them together. If you go to what we are saying Camel is, if you try to define what Camel is in a few words, we say Camel is an integration framework, and it's based on enterprise integration patterns. Oh, sorry, it's not like that. So it's only 2 words. So let me try to explain the first word and the second word, what those are. So as an integration framework, I actually like to picture Camel as a toolbox that has ready-made tools for you to use as a developer. So you can build your integration applications. So you can work with these tools at a higher level, a higher abstraction level, and build your solution instead of building those smaller pieces under the hood, which is taken care of by Camel. So when you start to learn the toolbox, like a hammer or a saw or something like that, then you know how to use it and you can reuse it again and again. It's much easier. So it's a standard set of tools, so to speak. Then what is enterprise integration patterns? Well, that's in fact a book with that same title. It's also a big book, almost the same size as this one. It's also written by, it was written by Gregor Hobby and Bobby Wolf. Those were consultants 15 years ago. They went from client to client and helped them in integration issues. And what they saw was the same problem over and over again. And what they did was to write down about these problems and how to solve them and so on. And then over time, they got more and more notes. And then they figured out, hey, maybe we could turn that into some sort of book. And what they did was to actually go to a conference where you can actually pitch ideas for books and whatnot. I didn't know that such thing existed, but apparently it does. So they went there and talked about to other potential authors, and they said, yeah, that's a great idea. Let's try to go for it. And luckily they did. So today we have this book published 13 years ago. This book is, some of you look not so young. So you maybe remember the Gang of Four book for design patterns, this is what we can say in the integration space is our design patterns book is the integration Bible. It's a very good book, and it's very rare in the IT landscape, because if you pick up the book today, the content is still relevant. It's not like you get the book, oh, this is an old book, you just throw it away. No, no. It's like this one. This is also very rare. You got it on video, right? Yeah. Yes. So in this book, we have recipes, as you may say, for solving common integration problems, and those are known as the patterns. And here on the slide, we have some of them. The content-based route is probably the most famous one. It's just like an if-else in Java, but you can filter message, you can send message to a number of recipients, you can dynamic route them, you can split them, you can aggregate them, and so on and so on. But this is a book, and Apache Camel is a software. So where does Camel come in? Well, Camel implements these patterns. And then you can go and use these patterns in what is called a camel routes. So the idea is that you can use camel routes or integration flow, if that's a better word for you, to define how systems are integrated. And the camel routes have a sort of like a mini language. We call it a DSL, domain-specific language. In that DSL, you can use these patterns and specify how the system is integrated. If you look at this code here, you'll probably realize that is fairly easy to understand. So it just says from to. So what we're doing, integrate something, picking up some files, and then we're sending those files to a DMS system on a queue called order. 2 lines of code. And Camel also allows to, yes, use XML. I said it. It's on tape. But it's true, yes. But there's also Scala and Kotlin DSLs and so on. But frankly, most people are using this. And the Kotlin and Scala DSLs are, yeah, well, not so much in use. It could be more in use, but apparently not. Because the Java DSL is actually quite powerful, and the XML DSL are actually also quite a lot of use in some big enterprises, because they have a lot of people, and they may prefer to not program as much. And they have some tools that can help define routes using XML, maybe graphical tools and so on. But even so, it's quite powerful, the DSL. So let's go and illustrate another thing I think is powerful with Camel, or also with the Enterprise Integration Patterns book, is that now we have a common vocabulary about integration. We have the design patterns, but we also have a graphical notation. So the idea is that you can actually align developers and architects, for example. So maybe you're talking about an integration problem and how to solve that, and you can go to a discussion, and there's a whiteboard, and you can draw, boxes and arrows and whatnot. But now you can actually use the graphical notation from the integration book. So, for example, we have a problem here. We are picking up some files. We need to split them line by line, and each line needs to be transformed from some custom format to XML, and that XML message needs to be sent to a downstream service on a message queue using a ActiveMQ. So now you can find the patterns in the book. There's 4 patterns. You have them illustrated on the whiteboard, for example. And now you can actually map that to Camel code or Java code. So you just say from file inbox, then we need to split. And we want to split the message body, and we want to split it line by line. So we can use a tokenizer with the nuke line character. Then we need to transform that message from some sort of custom in-house format to XML. I'm just using custom data format here as an example to tell you it's also possible with Camel. If there's some specific format that is not an industry standard, Camel can also use that. This is where you write a piece of code yourself to map from your custom format to XML. But if it's an industry standard format, there's some for healthcare and finance and whatnot, then they're out-of-the-box data mappers in Camel. And then the last line is just to send that to debugger. I'm sorry if you guys can't see it in the back, but these guys here in the front are responsible to acknowledge what I'm saying is actually right here. So I'm bribing these guys. Okay, so what is the architect of Camel? That's quite easy to see. There's one figure you need to illustrate. This is the one, the Camel architect. So what we have in the center is the Camel context. So what is Camel context? Well, Camel context is Camel. It's the runtime Camel. Then the idea is that you can add routes to this runtime Camel context. In this routes, you can use the enterprise integration patterns where you can use message routing, transformation, validation, enrichment, called business logic and whatnot. And then, to integrate to other systems, or as I say sometimes, to speak to the outside world, you use these Camel components. We had seen the file component, GMS component, but there's a lot of components. So where can you use Camel? Well, you can actually use Camel everywhere. Well, that is not entirely true. You can use everywhere where you can use Java. So if you have a Java or JVM, then you can run Camel, because Camel is actually just a library. It's a jar file, bunch of jar files you talk together. Now, Camel has been around for a long time. Yes, I've worked with Camel professionally for 10 years, so it's older than 10 years, right? It's 11 years old. But again, some people are not too young, but there was a time when the application servers were ruling the world, and Camel was created at that time. So it was a very good deployment model back in the days, was to build an application as a WAR file, year files or whatnot, and then throw them over to the wall to the ops people or the operation team, and they have like a Word document, like read the Word document and click, 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 click to deploy it, and we can run Camel as a WAR file in those app servers like IBM, Oracle, JBoss, whatever those beats were. But in modern times with Linux containers or Docker containers or just containers, Camel works beautiful there as well. And this is where we're going to focus a bit on in this talk. But again, there's no restriction in Camel. It's sort of just like a jar file. So you can also run it standalone or whatnot. So now, speaking of all these Camel components, I just want to illustrate with this slide. There are sort of like different categories where there's a lot of components for. We have the traditional enterprise system with messaging system, file-based, network, socket, database, and so on. Then you also have the big public cloud vendors like Microsoft, Google, and Amazon, of course. And then you have some of these software as a service online, Facebook, PeopleSoft, ServiceNow, Salesforce, and others. And we are constantly adding new components for these as well. But there's down here in the corner, there's an area as well, the IoT, small embedded devices. So Camel also runs beautiful there. Well, I have a smartwatch here. No, are you really telling me that Camel can run on these small embedded devices like sensors and whatnot? Well, of course not. I cannot run there. No. So in this IoT world, there's a way of where you typically have these small embedded devices running very minimal microprocessors and whatnot. But then you may have a gateway in between. So the gateway sort of is between those devices and then the backend system somewhere else. And this is where Camel fits well on this gateway, because that is still a lightweight microprocessor, but it's powerful enough to run Java, for example, and then you can run Camel there. Then Camel has connectors for all these IoT protocols like COAP, MQTT, PubNub, and others. Then Camel sits in between, and we have stories where Camel are doing that in the real world, all over the real world, helping with that. Then Camel has, of course, protocols and components for connecting to backend systems using different means. AMQP, for example. So just to summarize Camel, this is actually my animation, if you want. So this is Camel is this toolbox. Then we have this enterprise integration book with these patterns. You can go and use all these patterns in your Camel routes where you define how the systems are integrated. Then you have all these components where you connect the things together that can speak to the outside world. And all that together is Camel. That's a beautiful slide. I can go fast and forward, sort of like this was an animation. Okay, so what about Camel in the cloud? Well, this slide is lying a bit. When I'm talking about the cloud, I mean, I'm probably referring more to running Camel as containers. But I love this slide because it's a real cloud thing, and it actually looks like a camel. So I used it. So when I say cloud, I mean containers, Kubernetes, these kind of things. So, oh yeah, I have to stand a bit because I'm going to animate a bit. So when we start to running our applications as containers, then we are moving away from running as a bigger monolithic application to a smaller, to a more microservice architecture. So we are splitting up these bigger monolithics into smaller pieces, known as microservices. And then over time, those microservices become more and more independent, distributed, and networked. And now we have a different situation, distributed computing. And as we know from computing, this is quite hard and difficult. Now we have the service distributed, they're communicating over the remote network, they're running in different containers on different nodes and different hosts using different JVMs maybe and whatnot. And you have to manage and distribute and run your application there. But why are we doing this with all this pain if you could just chuck it all together in one big bloated monolithic application? Yes, why? I don't know why, damn. To sell more software? No, I don't know. Well, if we want to run applications in this way and everybody tells you this is the way, then it has to be probably easier, right? So it has to be easier, but we need some help, And where can we get help from? And what features do we need? So we need a set of capabilities, or now to play with the words microserviceilities. Yes, we made up a new word. Buzzword bingo. So in the slide here, we have a shape of 10. Deca. So it's a decagon. The Greek word for 10 is deca. So these are the features we need. There may be more as well. So where do we get these features from? I don't want to write them myself, and it doesn't come everything from Camel, even though Camel is great. So, we get many of these features from a container platform like Kubernetes. So Kubernetes makes it easy for service in the cluster to discover each other. It makes it easy for invoke service. It makes it easy to scale up and down service, so we get some resiliency, less toxicity, and also resilience. The container platform can sort of run your service in a highly available mode and then have self-healing and whatnot. We're going to see that in the demos as well. But there are more features. As a enterprise or developers working for real companies, we need extra set of features around, so you can build your application in a way where you have sort of like a CI/CD system that can, automate and run tests and promote things and whatnot, and then get them into different environments and run them in the clusters and whatnot. So we need an extra set of features, and those are not provided out of the box in Kubernetes. So there's a number of Kubernetes distributions that comes out of the box. Those are categorized as a platform as a service PaaS, and one of those are from, yes, this is where there's a little employment pitch. This logo down here is OpenShift, but there are others alternatives. And you can even piecemeal yourself to get a PaaS solution, but I don't think you should do that. There's better choice. But you also need, for example, ops people need centralized logging, monitoring, and whatnot. Now, in recent time, there's a new product emerged on the scene called Istio. Anybody know about Istio? Oh, quite. You are very clever down here. So there's a new kind of thing they coined as service mesh, or now it's becoming coined as cloud mesh. Well, Istio is trying to be a solution for managing and connecting your service in a more secure and reliable way, in a more fault-tolerant way in the cluster. So Istio provides additional features around resiliency, authentication, security around your service. It also around, helping something with distributed tracing, so you can kind of help know what's going on when you have a sort of like a transaction going across many different microservices and see what's going on. So Istio is part of that puzzle, and there are people in the community or in industry are talking about, Kubernetes and Istio sort of maybe belongs together, so it becomes sort of like an easy add-on to Kubernetes, or even a mandatory thing or whatnot. So keep an eye on Istio. Now, when you have a lot of microservice or application in a container platform, they communicate using some sort of contract, using APIs. And when you have a lot of those, you need to manage those and govern them and whatnot. So you will look for an API management solution. So you don't. So developers should be able to have a repository. They can find the APIs, they can read about them and see what they're doing, and then they can maybe try them. And they also, importantly, the APIs need a contract that are for computers, but also for humans. And maybe those APIs are protected. You need to have a sort of like API token to access and call them, or maybe there are policies around them, different meters like gold, silver level, and whatnot. So all that kind of thing, you don't want to write that yourself, and so you're looking for some sort of API management solution that can run in the cluster when you have more than one API, or when you have plenty of them. But this is a Camel talk, and I'm talking a lot about Camel, and there's no Camel logo, and where is he? Should Camel just be booted away because it's not gone? There's no need for Camel. So where is Camel? Can anybody point to where Camel will be on that slide? Everywhere. That's a good question. A good answer. Kevin taking over the world. Oh, yeah, it's like that. If you hit bullseye, then there he is. So Camel is with your service. So Camel is embedded together with your applications, your application or your service. Now Camel requires Java. So Camel can only work with the Java service. So Spring Boot, this is Vertex, this is also Java library, and this is the Wi-Fi Swarm. But anything in Java, Camel can run. So not with Golang or Node. But we'll see later. You can use some of these things with Camel in a new product. So the idea with Camel is that you embed together with your microservice and use it for integration needs. So for example, if you have 3 services, you only need to use Camel where it makes sense. Sometimes people, even me, I would say, use Camel. You have a problem, use Camel. Use Camel. So now, it's like that golden hammer, right? Everything is a nail, you just want to use it. So that's the problem. So only use Camel where it makes sense, but Camel is adaptable, flexible, lightweight library, so you can actually easily embed Camel where you want to use it. So in this situation, we had 3 services, A, B, and C, and apparently this time, Camel was only needed in A and C. So that's semi-good. No, it's still needed there. No, I'm just kidding. Only use Camel where you need it. So for example, in this cluster, you need to integrate with some external system that runs outside the cluster. And that system could be an Oracle database or something like that. So it's not like a hipster thing. So you can't get like a Go guy or Node guy, tell us from JavaScript or whatever. So with Camel, there's 200 or so components. And using Java is rock solid and whatnot. So you can find, any kind of Java developer can easily, integrate with an Oracle database using JWC or some SQL or whatnot using Java technologies, and even easy with Camel. So it can make sense to use on these edges to integrate with all kind of existing external systems. So what are some of the good practice of, I don't like the word best practice because not everything is just like super best. What are the good practice around running Camel in containers or in the cloud? So you should try to build your microservice small in size. And recent time there's these container kind of thing, runtime container kind of thing in Java that is sort of like a fat jar thing. You just bundle everything together what you need, not like an external app server where you put it on the app server. Like Spring Boot is very popular on that, and others are offering similar capabilities. Wi-Fi Swarm, Vertex can also do that, and there's also a main for Camel, so you can also just use plain Camel. But that's a good choice. So Camel also comes with 200 components. You just piecemeal and I need that component and then Camel, and only use that. That can be small. And we are working on making Camel even smaller for Camel 3, which is the next version. I will talk a bit about that at the end of these slides. So today Camel Core is around 4 megs. In the future it will be even smaller and faster and lighter and all the goodies. You should also try to build your application as stateless. Stateless applications are much easier for a container platform to scale up and down and whatnot and manage them. And if something goes wrong, you can restart them and whatnot. But if you need some sort of state, there are Camel components that can, integrate with a stateful service like a memory grid or whatnot, like JBoss Finispan, Hazelcast, Apache Ignite, and others. But there's also like persistent storage with, SQL databases and Kafka and all these kind of things. And then the Kubernetes platform itself comes with a concept for stateful applications called stateful set. So some of these containers is running in a stateful manner. You can specify them as a stateful set and let the container platform assist it and run them for you in that manner. Now, another important piece around microservices in containers is around configuration management. Because when we are building microservices for containers, we're actually building them as a static image, as a Docker image. And then the idea is that the container can boot up and it can easily process a container for that. But you want your configuration external from that image, so you can modify your configuration. So that's why you want to have that separated. And Kubernetes comes with 2 concepts for that. One is called config map, and the other one is called secret. Both of them are just like key value pairs. And you can get those information injected into a container. So when Kubernetes boot up, it injects all these config maps as environmental variables or as files on the file system, like key value pairs. And those 2 differences is the same. The only thing is that secrets are used for sensitive data like passwords and certificates and whatnot. That's the only difference. Now, the clever thing about this approach is that you don't need any Kubernetes client as a developer to access that information and get that information. There's no Java client for Kubernetes to access that because it's very easy to read environmental variables from Java, or even read just a properties file. Anybody can do that in any programming language. And even some of these runtimes like Spring Boot and Camel itself has support for that out of the box, so you don't have to do anything. So in Spring Boot, you can use this add value and then refer to the key with this $squiggly notation. The key is called fallback. And in that, there's a config map from Kubernetes with the key here, fallback, and the value is, I still got no response. So that's a way of doing it. Now, this is very important as well to build your applications or microservices in a fault-tolerant way. Now, I said that Kubernetes comes with support for that out of the box. It's sort of like a highly available cluster. And that's because the Kubernetes itself kind of monitors what goes on in the cluster, and it notices that if something is not correct, it can self-heal. And it's based on the principles of, what do we call it? Declarative state. So you say, I want 5 of these and 10 of those, and then you'll just let the cluster decide where to scale and orchestrate and run those. And it just keep monitoring. Are there still 5 of these running? Yes. Now 1 is died, or sometimes there's only 4. Okay, I need to create a new one or restart one of them. So that's the thing, the happy state. Now, but there are still problems you need to be aware of as a Java developer even. So you have to build your Java applications in a more fault-tolerant way, because errors can still happen, which we're going to see in the demo. Camel comes with 2 concepts for that. One are the client-side retries, and the other one are based on a popular pattern around circuit breakers. And Camel comes with the implementation of that using the Netflix stack, Hystrix. And the circuit breaker thing and the client-side retries, those are Java technologies built in Camel, and Netflix is also Java technologies that you, as a Java developer, has the power of using. But just want to add a side note that this is also where the boundaries of this service mesh thing or cloud mesh thing is taking over with the Istio product, because Istio comes also with some primitives for running, retries and circuit breakers. But those are external. Those are not Java-based. This is something you configure in Istio itself, so sort of separate from your application. And this is more potential the future, and this is still very good, but it gives you, as a Java developer, in your hands. Now, for example, with the retries on the client side thing, so we have a service that we call this hello service over here. If it fails, then we try again and again, and then maybe the fourth time it works. That is a good approach in some use cases. Yes, I'm using a common example is money transfer. So I send you $100, and your service fails, and I just that's fine. You never get your money, right? But you want your money probably. So okay, I'll wait a bit and I'll try again. So there are some use cases you definitely need that, and then there are some use cases where you don't need it. And we can see that later, because we can get to a problem with this approach of retrying every time. It's called the thundering herd problem. So if you have a service, maybe you're apparently the Italian money service. Everybody sends you money, and because you got so many requests all the time, then you cannot handle it, and then the sending money to you fail. But we all just retry. It doesn't really help you, because we just add more load to you. So your service gets under stress. And this is the thing with the thundering herd. It's like a lot of cows coming running towards you. You cannot do anything to say stop. No, please, cows, stop. Come back. Just give me a minute, please. Sit down. Go eat some grass or whatnot and come again. No. So there are other patterns for that, which we're going to see in a bit. Very important in running your microservice in the container is to also have health checks, because you want your application to be able to say, I am healthy, I'm good, or I am not too good. And that's what you use health checks for. Some of the popular runtimes, Spring Boot or Wildfire Swarm, has some help for that. Spring Boot is called actuators, and Wildfire is called monitors. Those are tied together with the Kubernetes platform. They are known as probes. So the intention is that Kubernetes has probes where it actually keeps executing these probes to check the health check. There are two kinds of probes, the readiness probes and the liveness probes. There's a big difference between them, and then there's not. So it can be important to know the difference, but sometimes they are using the same check, like the actuator in Spring Boot, but there's a difference to it. You're going to see that in a demo. I will not give you too much information now, but just keep that in mind when we see it in a demo, and we can talk a bit more about it. So what about this enterprise integration patterns and running those in the containers? Are there any good practice around that? No, they just work anywhere. Those patterns were created 15, 13 years ago, before the cloud, before container and all that kind of thing, but these are universal. You can just freely go and use them there. No problem at all. So that's good. So coming back to the circuit breaker thing. So Camel comes with implementation from the Hystrix. So the intention is sort of like this state up here. Then in Camel, you can actually specify, okay, I want to use this Hystrix circuit breaker. So anything that goes in between here is protected by Hystrix using that circuit breaker. And then you can associate a fallback to the circuit breaker. If something goes wrong, then the fallback can be executed. So it's like a try-catch, but a more powerful try-catch. You're going to see that in a demo as well. So the intention with the circuit breaker is that it has a threshold limit. So you can configure it quite fine-grained. But if a service starts to fail after a while, you can kind of regard it as as failing, and then you can go into the open stage. So you don't call the service anymore, you just call the fallback. And then you let a small percentage of these requests go through just to check you, are you becoming okay, so you don't get under stress. And then if you start to accept those requests and the successful responses back to me, then after a while I can start to recognize, okay, he is actually good again. I can start and go back to being good again, closed. Now, if you're not colorblind, and this is what it really is confusing, is because it has this statement called open and closed. So you may think, open, that's good. The bar is open, I can go and drink beers. No, that is the bad thing, because the circuit breaker is like the power circuits in real life with currency, like electricity. So if there's a spike there, something goes wrong, it can flip up, so the electricity cannot pass through. It's like a bridge. So it's the reverse thing, kind of thing. So maybe if you can see the colors, green is good and red is bad. There's another pattern I just want to mention around a microservice or containers. Is around distributed transactions. It's called the Saga pattern. So traditionally with app servers and the likes, Java EE thing, we had sort of like distributed transaction coming from the app server, but it was supported only for a limited number of resources, typically JMS and JDBC. So that was the only use case you had. You can pick up some JMS messages, you can save it to a database, and you can do that in a distributed two-phase commit transaction. But anything else couldn't work with that. Now, when you have distributed computing with the cloud, there are other means of transports and whatnot. So there's actually a pattern for that called the Saga pattern, and Camel has integrated with that, where you can sort of add the rollback actions. Those are called compensation actions. And then, there is an external system that can orchestrate that for you, sort of like a transaction manager. There's one implementation of that today. It's from it's being driven as a specification as part of the Eclipse microprofile thing, called LRA, long running action. So there's a Camel component called Camel LRA, and in that you can use one of these implementation of that spec. And there's one today from Jebos Narayana. It's a hard word to say. It just happened to be that it's a transaction manager as well. So the team behind that knows a lot about transaction, distributed transactions, so they can also implement that for the specification. But that was a lot for that pattern. But just know there's something around distributed transaction in the microservice. Well, you're not lost. It's still there somehow, and you can use that. The last piece is around distributed tracing. I talked about, when you, instead of one big monolithic, you have microservice in that cluster that run everywhere kind of thing. And then, something, user click here, and then something goes wrong. You don't know what are the route path that transaction took. So you need to use distributed tracing to kind of trace what's going on. So they kind of leave some breadcrumbs around the carrier across. And those messages get then logged. And then you can have a visual tool that can visualize that. Jaeger UI, open source project. I think it came from Uber. So you can kind of see what's going on with different microservice calling it, and you can see the timing and whatnot. Just to go back to the previous slide, there are two popular open source projects around distributed tracing, Zipkin and Open Tracing, and Camel has components for that as well. So to go back to this decagon, so where we have Camel in the center, but Camel also assists a bit with different, so for resiliency, there was these client-side retries, there was also this circuit breaker with Hystrix. Camel makes it very easy to invoke other service, comes with 200 components. You can also invoke service outside the cluster, all kind of protocols. Camel also has some good support for RESTful APIs. There's actually a variation of the Camel DSL called the REST DSL, where you can easily set up REST service or call REST service using REST terms like get and post and whatnot. And then for distributed tracing, we saw, Zipkin and whatnot. So there's some. So I wanted to have Camel logo on the outside as well. So it makes sense. So So now it's about demos, and this is where things can go wrong. And can anybody see what that is? It's a camel. This is my, he cannot hear it. This is my favorite camel. No, you are. This is a Lego camel, right? And I'm from the country with the Lego, yeah? But unfortunately, I have not found this box in a Lego shop. But I want that. So if we get to that, awesome giveaway, right?
There's a shop near Milano.
Okay, let's go to the shop and I demand for the camels. So yes, it's a very basic demo, hello service and a client calling it Camel build places. So using HTTP, calling the service, get a response, and you can log it and see it. So just to be quick and easy. So the client Camel route is actually implemented with using the circuit breaker. I used to have a longer demo where we didn't have the circuit breaker in the beginning, then we added it later. But just to speed up things, so we call the service, but it's protected by Hystrix. If there's an error, we just say nobody wants to talk to me, and that's it, and then we log it down here. On the other side, I'm actually not using Spring Boot there. I'm using Wi-Fi, and there it comes with under-top HTTP server out of the box. I just say /hello, call a Java bean. The Java bean says, Swarm says hello from, and then we want to get the host name. So there's a little inet address util get local host name. This is because we're running in a cluster. It's dynamic host name, so we want to see if we kill applications, whatnot. They're getting a new host name, so you can see it's scaling up and down and all that kind of things. So that's it. And let's see if we get it. So now it's where we cross the fingers and see if we can see. This is a shell just to say, it's actually quite, yep. So if I refresh this page, so you guys can see I click this one, right? So it's live. So I'm calling the service from a web browser saying Swarm says hello from, and you can see the host name over here is dynamic. Okay, but I have already implemented those demo, and I'm actually running that in the cluster. So I can say kube get pods. So kubectl is a command line tool for Kubernetes. You can ask to get access the cluster, and you can manipulate it, you can do all kinds of things. And there's something called pod. How many people know what a pod is? Okay, so this is also coming from computer worlds. It's actually quite funny. So I thought it was a process operation daemon, something like that. Or whatever, Okay, yeah. But, Docker sort of made containers technologies more accessible and popular and famous kind of thing. And Docker is that whale, the logo with the big whale. And the English word for a group of whale is actually a pod. So a pod of whales. So they come from that nature term. And it's actually quite describing in Kubernetes because a pod is the minimum deployment unit in Kubernetes. So you deploy a pod. So that implies that you can have one or more whales or containers. But often you may only have one container running, but it might be 2 or 3 or 4 or 5. And there are some patterns for running application in containers where you can run additional containers as a sidecars and ambassadors and whatnot that can kind of facilitate your application. One of them will be around this service mesh thing with Istio, because Istio will actually be a sidecar running it. So we actually end up having 2 now instead of typically 1, because Istio will take over as the sidecar and do the network communication for you. So you communicate locally host to the Istio sidecar, and the sidecar does all the other thing, but not here. So what we see here is ready state. So there's 1 does 1. That also means there's actually 1 container running and 1 of them is ready. So that's what you can see. I have only 1 container in each of them. And you can see how many age they've been running. So 169 days. So that was the time when I created this cluster. So some of this demo is 169 days old. Okay, so we can see we have a client and a server here. So what I want to do now is that I actually just say I want to follow the logs of the client. So I say client Hystrix for, and what you should see is that this client will just keep calling that service, and then we can do stuff with it. For example, I can say get pods, and if I say delete that, delete pod. So now I'm deleting the pod, and you can see up here nobody wants to talk to me because the circuit breaker kicks in and detects there's no service running. I cannot communicate it. I do the fallback, and that's fine. And then after a while, it should of course hopefully come back because the service. Now we see it comes back. And this is because it's the clarity state. The heavy state was that there should be one hello swarm running, or there should be one client running. So somehow it was deleted, but it's just restarted. So that's the way of restarting stuff, is to delete it. Okay, so but now we don't have really a fault-tolerant application because there's only one of them. This is a container dynamic. It has elastic thing. Why not scale it up to 2? So if you delete one, the other one will just keep running. Good idea. And for scaling up to, I will just go here because I will just show you there's a little web console from OpenShift. It just has this nice round circle here, and can just click the button. I'm scaling up to 2, and we should see here this guy should start to call the 2 service. And yeah, okay, yeah, don't see that, no. Oh, damn, beer time. Now, okay, it's scaling up to 2, and then you can see here. Okay, now we see it. This is now you can see there are 2 different. Okay, so it calls 2 servers. That's good. And now there's 2, right? But can anybody tell me what is the algorithm for calling these 2 services? Is there any? There's only 2, but the client calls. How does it decide which one to call? Round robin. Okay. No. It's well. It's a drunken round robin, apparently. The question or the answer will be correct maybe 2 years ago or thereabouts, 1.5, 2 years. But now it's not correct because Google and those guys, they start out with round robin because it makes the most sense, right? We call a service and then call the next one, even distribute. But I actually figured out now there's some sort of predictability around that, and it can actually cause more errors because they're sort of like, okay, I call and then some errors. So they did some analysis and found out it's actually better just to do random. Yes. So even there are 2, it's calling random. But of course, everything with Kubernetes is very flexible. You can choose. You can just say, I know Google guys, and you're better than me. I understand it better, but I don't want to call it randomly. I just choose to be round robin. Yes. Or implement my own, if you want. Or in the future, let Istio decide. But okay. But there was another problem.
Is it possible to create a policy to invoke the service with less load?
That's a very good question. And yes, you can. You can implement your own policies. You can implement your own algorithm for that. Out of the box, there are only these 2, right? I will see that it's probably where we will go to Istio and these products to be more powerful. That comes with these things out of the box, so you can configure and use them. But you can implement them yourself also. And even so, there is also possible for you as a Java developer in the client side of things to decide and call a service directly. There is a Kubernetes Java client you can use that can communicate with the cluster, get a list of physical nodes where it's running, and then you can actually also get metrics around them and choose which one. You can use it in special use case. Maybe also it's decided on based on priority of the customer or whatever, that's whatnot. But I'm just saying that some of these problems are what other companies have also. So the more people have the same problems, there will become better out-of-the-box solution for that. But going back to that first one where I'm jumping up and saying, why did I do that? Anybody? This is where you can win the book, maybe. Why did I tell Kubernetes, I am scaling up a service from 1 to 2. Please be good at doing please be good at that and do that in a highly very resilient way. Don't give me errors. I'm telling you, I'm going from 1 to 2. And why is there still a problem? What? Wow, have you read ahead in the slides or what? You sit with the review, you can cheat. You're correct. So the problem is that when you build your microservice, you also have to consider that when it's ready, readiness probe. So in Java, for example, it takes time to boot up a Java JVM and be ready for accepting traffic. So when you boot up Spring Boot or Wi-Fi Swarm, in this case, it takes a little while for Java to warm up and then get that HTTP server embedded server ready to accept traffic. So what I did was actually to cheat. I was lazy, so I built that application without any readiness check. If I added that to it, it will actually wait. Kubernetes will use the readiness probe to know that it's not ready yet. When I boot up the second service, it will just keep calling the first one. And when the second service is ready and says, yes, I'm ready, it will start to call it again in that random thing. So it's very important to have readiness probes in your application when they boot up, especially when you host a service that others can call. But also when your service is running all the time, you need to have health checks embedded because your service itself could start to crumble. The JVM could start to run out of memory or something else can go wrong. Then you need to say, oh, I'm not so healthy anymore. Please kill me or restart me or whatever. So health checks is important. And those are readiness probes for starting up and also for liveness checks for keeping healthy. So those are the things. Very good. So what can I else do with the demo? I have to consider. Yes, I forgot. Let's just go back to 1 again. And there's also, you can read this one. This is the extended one is that I'm just demonstrating that you can actually go outside the Kubernetes client tool and use Docker directly, Docker PS to list all the containers running, and I can actually go and kill that container if I can find the container ID here. And so in that situation, it's more like a real life thing, because maybe a rack goes down or something, a real accident happens in your cluster, and then that fails, and then the cluster detects it, and then it kind of self-heal it. The other thing I did was actually telling the cluster, delete that one. So it actually knows what's is supposed to delete. But you can simulate that as well using the Docker PS and Docker kill and then the process ID. But in the interest of time, I'm skipping that one. And I forgot to add this guy. So I'm just going to go down here to, there is also a dashboard for the circuit breakers. So what we see here is the circuit breaker for the client calling that hello service. Is green, 10 service is successful per whatever period it is. The state is closed, the bridge goes like that. Just like the colors, green color is good. So what I can do as well is to go and kill that one. So again, I can just say Kubernetes. So now I'm killing that guy. And this guy should start to rack. You can see the dashboard starts to say, okay, there are 4 errors. One is the probe. Now 85% of them are failing. 100% are failing. So everything is errors. Circuit breaker is open. And then after a while, it will actually go back again. Now it starts to become successful again, and it goes. Now this circuit breaker is very quick at going up and down because I have adjusted the threshold for it. This is 1 request a second is very low performance or whatever. Out of the box, Hystrix is sort of configured for Netflix. There might be a bit more activity going on there, right? So this one will not say one error, one, that's no problem, you know. So you have to fine tune it a bit for your need and how often you want to react and so on. So I did that in this example. And also not to say here, do a dance or whatever, because it takes a minute or before it detects it or whatever it does. But you can choose. And this is a cluster-wide one. If I have more circuit breaks, you can see all of them on this one. But again, you know, this with Cloud Mesh and Service Mesh coming over, they will also provide, you know, dashboards for that and whatnot. So I think that's the guy for this demo. There are going to be more demos coming. So let's just go continue on the slide a bit soon. So this slide, everybody should be able to read, also from the back. No, I'm just saying this is a triangle. This is a figure that Bilkin created, and a good blog post about some of these concepts or primitives around containers that are in there. So I'm just saying that when you go from maybe like me, a traditional Java background, building Java EIP servers or whatnot, WAR files for Tomcat and whatnot, it's all Java libraries and whatnot, and you know, throw it over to the ops people and they do whatever they do. Now with containers, we are leaving a bit that Java land and becoming more wider. It becomes more Linux, containers, Kubernetes is more scary. So we need to know something about how does load balancing, security, storage works, and all these kind of things. And there's many concepts. And some of those are from the Kubernetes, some are from the lower layer, some are for higher layer, and so on. And there will be more in the future since this one. I'm just added it to slides so you can, you know, from later on you can download the slides and you can read these words and see them. It's just to, or maybe if you've been in the IT industry for a while, you actually know it's the inverse pyramid. So you know nothing and there's more and more to learn. So flip this around and you can work for another 20 years and still know nothing. So now we're going to change a bit. I'm not sure. I'm in between pizza and beers, but I just wanted to talk a little bit about the future of Camel. So we are working on Camel 3. We are about to kick off Camel 3. We already started some work on it, but we're going to do it in a blast. So in between the Camel 3, we will do plan to do a last Camel 2X release, 223. And 23 is quite a high number for release. You know, an architect of Camel 2.x, 1, 2, 3, 4, 23 releases, and these are quite big. So it's been around for 8 or so years on the 2x architecture. So it's a time we do a new Camel 3. And we want to do a time box release, so it's not going to be forever. So in the summer 2019, 3.0 comes out with whatever features we have ready, and then 3.1 and 3.2. We also know that I haven't shown you the Camel website. It's actually on purpose because it's like the Internet Archive. If you actually go to the Internet Archive from 2009 or whatever, when it was created, and look at find the front page, and then you go to 2018 and look at the current front page, it's like, okay, which one is the new and which one is the old? So we are very conservative. So we also need a new web page and documentation. And we're actually doing that. We have a new logo, this one. So it's much better. And we are migrating all the existing documentation. There's more than 1,000 pages, even bigger than this book. We have migrated all the documentation for components and whatnot. And we have a procedure now, a build procedure. So every time we add some new options to the components and whatnot, those are actually in the source code, even the documentation, so that we take out and slurp into the documentation so they're always up to date. In the old days, we had to add that later on a wiki system. What we need to migrate, the last pieces are the user guide, and maybe even write a better user guide. I'll just say, go and buy this one, and you have the best quick start for Camel. So what about Camel 3? There are a few things I want to talk about. There's more to come to announce, but we also experiment in running Camel on Graal VM or Sustain VM. Anybody know a bit about that? Graal VM Okay, that's like quite interesting because, you know, especially for containers, when you boot up a Java on containers, we saw it with the readiness code. It may take 5-10 seconds or whatever to boot up Spring Boot or Wildfire or Camel, whatnot. So what we're doing with the Graal VM is to have sort of like a ahead of time compilation, so you can build a static binary and boot that up very quickly. So we have a prototype of Camel. It's actually JavaScript, and Camel itself is started in 1 millisecond. But the Graal VM requires third-party libraries to support itself. So it's not only Camel itself, but also the other frameworks, Spring, for example, and many others. So when we get to that point, it will maybe be only these 80 components support Graal VM, and these does not, and we will add to the documentation so you can see it. Now, a new thing in Camel that was just actually announced yesterday is called Camel K, or Apache Camel K. K is, for Kubernetes, but also for Knative or something like that. It's a very so the idea is to write Camel with a K. It's a lightweight integration framework for containers or maybe serverless world kind of thing. And you can go on GitHub. It has a home there, Camel-K, and it was also announced yesterday by one of the leading developers on it, Nicola Ferraro, or Nicola, I think that's his Italian name. Sorry, you may take it out. So this is Italian made. It works. Nicola is based in Rome. Luca is from Milan. So, and we also have Andrea working on it. He's also Roman. So we have great guys, the awesome engineers. They work on Camel. Now we also work on Camel K. So it might be an opportunity for them to come here as well and talk more about Camel K at a JUG. And Mario, you can probably reach out to those guys. So I have a little demo for it, and just to illustrate a bit how it works. So there's a command line tool written in Go. You can use as a developer. You can write your integration code. The idea is just, I'll write some integration code and then Camel, run it. I don't really care. Then on this cluster, there is a Camel K operator. So there's something called an operator now in the cluster that kind of orchestrates all that for you. It's sort of like a clever orchestrator that can figure out, okay, this integration code, is it Java code, is it Node code, or is it JavaScript, or is it Kotlin, or is it something else, Groovy? And then it can compile it and to that, and find an optimal way of running it. And then it can run it in the container and using these something called custom resource definitions in the cluster for that. So it actually becomes sort of part of like an add-on to Kubernetes. So you have existing Kubernetes tooling that can understand these custom resource definitions and work with them. So let's just try a quick demo of that. So for that, I need to switch over to my Camel. So it's actually just the same. I have an operator running in that namespace. And now there's a Camel command line tool. If I can remember. This is very early version 004. And I can say camel get. There's nothing running. And then I can say, okay, let me run something. And I actually just prepared a bit here. So we have a little camel route in Java from a timer, setting a body and logging it. Now I want to run that. And let me see if I actually have it here. Camel. Oops. No, this is Camel. So Camel run, and then the name of the Java file, and then dash dev. Dash dev means that it runs in development mode. It logs, details the log, and show it on the screen here. So now it runs. We have Camel running 2.22.1, and it says hello Camel. 5 lines, 1 second, right? So now I will side by side, if I can, come here and I say, it says hello Camel. I say, oh, do I spell it correctly? Ciao, and save the file. oh shit, it's Italian made, it doesn't work. Ah, yes. Good. It was my error. So you can see I have not rehearsed it. /n, JUG Campbell. Let's just say camel delete sample. Okay, so there's, but that's because it's version 004. So I'll just say damn Klaus. Save. Yeah. Okay, so now you can see that. Okay. So, and anybody coding JavaScript? And this is just to illustrate a different example. So we have a little JavaScript run from a time again. Now it calls a DNS component in Camel to get an IP from the yahoo.com and log it. Just before we get to the beers, it's the same principles. You can Control V, run that one. Oh, log. Damn. Now I forgot to --def. Now you can see it down here. This is the DNS name. And now see how fast it was. This is JavaScript. Now I forgot double Klaus. If I say Google, yeah. Did I not say? Ah, yeah. I didn't run it in dev mode. That's why. Delete DNS. Camel run. I need to this. This is cheating. So dev is the one that keeps on monitoring and redeploying and whatnot. Again, it's an early. If I change it to Yahoo, you get the idea, right? You get that instant update, more or less. Now imagine that, Camel on JVM was growl, so very fast. But this one is actually using a Camel DNS component, so there's an extra component. So the idea is that Camel, this tool also comes with auto detection of your Camel components you're using, so you don't need to specify the class path. So it can detect, okay, this is the DNS component you're using, the FTP component and whatnot, and then it also figure out to what dependency you need, and then they actually build a container image that has those if they are missing. So the first time you start to use a new component that hasn't been on the cluster already, it will build a new base image with that one, and then it will run that one. So the first time it may take a little while, and then afterward it's just quick and early. That's pretty clever. So every time I do a source code change, it doesn't build an entire new Docker image, because they can reuse all the other existing images that are there with the components. And because the source code is a custom resource definition in Kubernetes, the operator can detect the change in those custom resource definitions, and then create a new container based on that, based on the other Docker image. That's why it's so fast. And this works in an external cluster. Even though it runs on my machine, you can be in a big cluster in your company or in the cloud or whatnot. So, but again, getting Luca, Nicola, Andrea, whatnot to come here and talk about it, and you can even get it in Italian.
Or you can learn Italian.
Cool, yeah. Ciao. Beer. Now, speaking of Italian, I have another surprise. This is the, yeah, we'll get back to that. This one, and we'll get to it. I have a friend called Filippo. He's actually Italian, but living currently in Denmark for 10, 15 years. And as you can see, he's very exciting because it's actually his birthday, and I cannot be, well, on Saturday, he's throwing a party, and I cannot be there. So I want your help. So This is Google translated. I hope it's correct. It's supposed to say happy birthday, Filippo from Milano. But okay, so let me just take a moment to record a video. And just to say, and there's two parts. One is in Danish, what I say, and then Hej Filippo, jeg kan desværre ikke være med til festen, men jeg har fundet nogle andre venner her, der kan hjælpe dig lidt. Vi har en lille hilsen til dig, så den kommer lige her i den næste video, så stay tuned. And flip it. So I'll say 1, 2, 3, and then and you can also say something else after that, you know. Oh, maybe I need I'll just go here, and then I'll turn around, and then you. Please go ahead. You forgot it. Hey. Wow. Thank you very much. Now he's famous, yeah? Okay. So just before we go to the beers, this is very important. Free books. We like free books, right? Download them. This is sort of like how to use Java on containers. This is sort of introduction to Istio. If you want to learn about Kubernetes, then there's and Istio, there's actually just announced Istio in action, currently being written. Takes some time. And this is where you're gonna take up your phone now, and then you're gonna order something. Yes, there's one free book, and we have to. But Matej had the answer, but he's also the video man, so that is maybe cheating.
You can decide, or we can raffle if you want.
Okay, yeah. But if you order it from the published website, there's a Camel 39 discount code. And to keep on saying that, this one works forever. But sometimes they give a special discount, like 50% or whatnot. So you can actually try to see if you can find one of the order codes that may work at the time. So try with Camel 99 and 98, 97. And, you know, just do it every day and suddenly you get it. And we have said hello, Filippo. And okay, so the slides and the demo is on my GitHub account. There's something called Camel Writers in the Cloud. There are some branches for different talks. Go there. The Camel website, yeah, go back 10 years in time. You can see it there. What is Apache Camel? If someone asks you, you can point them to this article. It's still very good, a bit old. My blog, I sometimes write about Camel, and then the exciting new Camel K thing, Italian made, so it works almost the time. So Nicola and Luca and others can come maybe and give a talk about it. And now we go to beers almost. Any questions before? Or I'll of course also be around for beers and whatnot. The only one is the book, how to raffle that. Any good ideas? Should we just raffle?
We're using Camel in production for I found very good Camel in action because it's a good tutorial that express concept about ideas, good ideas. But I think we need something like a reference. And this thing much similar. Sorry about my the English.
No, that's good.
Yeah, okay. Is I think JFuse tutorial, but it's not only about Camel, but other technologies.
Yeah.
Some suggestions.
So yes, so this is where open source products often have a problem, is that writing good documentation or tutorials or videos and articles and whatnot, and probably more when it goes more out of scope of that sole product itself. And this is where you have to rely on maybe consultants and other people doing that, but it's maybe based on their volunteers and whatnot. Maybe they have an interest, and then to find good professional documentation across that is harder. There are some companies that are having online training things, and they build some sort of like a material for that, and there's like a quiz at the end. There are companies that offer professional on-site training. They can come to you and talk about it. And then there's Red Hat I work for. They also have training for Fuse. This is the product for Camel related to that. But all about, yeah. But it was a good question about there's good material in the book. Yeah, that's the thing. Okay. So, okay.